What if every civilization that ever existed on this planet began not with a birth, but with a silence? A silence so complete that even memory itself could not survive within it. So before you get too comfortable, take a moment to like the video and subscribe. But only if you really like what I'm doing here. And tell me, where are you listening from? And what time is it there? In your corner of the night, the Cretaceous ended not with a roar, but with a long, low exhale of the Earth itself. 66 million years ago, something vast fell through the sky. A visitor from elsewhere, its name written in iridium dust. The impact site we now call Chicxulub is a scar that never truly healed. Oceans boiled, forests burned to their roots, and for a moment the atmosphere was made of smoke and glass. What followed was not merely extinction, but amnesia. More than 3/4 of species vanished, and the planet itself seemed to forget what it once had been. When the light returned, it was different. The color of the sky changed. The forests grew back in silence, thinner, uncertain, as if the Earth were hesitant to remember itself. For tens of thousands of years, the world lived in aftermath. Oceans full of drifting ash, rivers thick with carbon black. And yet, within that hush, life began to move again. The first mammals crept from the margins, blinking into a world without thunder lizards, without shadows taller than mountains. But here lies the contradiction. The fossil record shows recovery almost too fast to be real. In less than 500,000 years, a blink in geological time, ecosystems reassembled, new species appeared, and the old order was gone as if rewritten overnight. Could life have been waiting in hidden vaults, preserved in deep caves or under frozen soils? Or was the catastrophe less total than we've been told? A filter, not an ending. Some geologists suggest the layer of impact debris is uneven, missing in places where it should exist, as if the record itself were edited. In the earliest Paleocene sediments, we find strange creatures. Archaic mammals with reptilian skulls, birds with teeth, plants that seem to belong to two epochs at once. They exist like echoes, transitional, uncertain, incomplete, a world rebuilding itself from memory fragments. Why does this pattern feel familiar, almost human? The moment after trauma, when the mind rushes to fill its own gaps with dreams. The Earth was dreaming too, and out of that dream, the age of mammals began. Somewhere in the swamps of what is now North America, small hoofed animals like Phenacodus roamed among ferns that had survived the firestorm. In the rainforests of what would become South America, primates the size of mice darted across vines. Yet the air itself carried a secret. The carbon isotopes locked in those early soils tell of a planet still struggling to breathe. The balance of oxygen and carbon dioxide was unstable, swinging wildly, as if the atmosphere were haunted by what had burned. Geologists studying these layers found something else. A curious pause. After the impact boundary, there is a missing few thousand years in some cores. Sediment that should exist, but doesn't. Was it eroded by floods? Or did the Earth simply stop recording for a while? If strata are the diary of the planet, this was a page torn out. And in that missing page may lie the origin of the Cenozoic's greatest mystery. How life recovered, reorganized, and reinvented itself with such impossible speed. One hypothesis whispers of subterranean refuges, microbial biospheres deep beneath the crust that never noticed the apocalypse above. When the surface cooled, these hidden cells rose again, seeding oceans and soils anew. Others speak of cosmic cycles, that extinction is not random, but rhythmic. The result of Earth's slow passage through unseen belts of debris, each impact a punctuation mark in a greater sentence. But who, Or what writes that sentence? If we look closely at microfossils, we see discontinuities in the story we tell. For instance, foraminifera, tiny shelled organisms that measure time more accurately than clocks, vanish entirely at the boundary layer. But their replacements appear so abruptly, with such diversity, that some paleontologists have compared it to a creation event. Not divine, perhaps, but something beyond simple evolution. What could drive life to bloom again so quickly after annihilation? There is an unspoken idea among a few researchers, quietly passed between conference papers and midnight emails, that our understanding of extinction is incomplete because we have mistaken the map for the territory. Perhaps species do not vanish but retreat into genetic latency, into forms of dormancy we have not yet imagined. Could the code of ancient life sleep within modern genomes, waiting for the right environmental chord to awaken? In the Paleocene, maybe the Earth struck that chord and old melodies rose again. Yet even as life returned, something fundamental was missing. The great reptiles were gone, and with them, the deep time perspective they represented. For nearly 200 million years, they had ruled continents and seas. And then, silence. No witnesses remained to remember them. The first mammals inherited a world of ruins, but no history. It is strange to think that everything alive today carries within it the memory of that void. When we stand on limestone cliffs or hold a piece of amber to the light, we are touching that silence, the residue of a world erased and remade. And perhaps, deep down, that's why the Cenozoic feels both familiar and uncanny. It is not merely the age after dinosaurs. It is the first act of forgetting written into the Earth's own mind. At night, when seismic instruments hum across the planet, they record more than tremors. They capture the heartbeat of continents, the slow drift of memory beneath our feet. Each wave traveling through stone is an echo of that first silence after the fire. The moment when the Earth paused, exhaled, and began again. We often tell the story as if it were simple. Impact, darkness, recovery. But every new discovery complicates it. Chemical residues in ancient clay hint at acid rain that lasted centuries. Fossil pollen shows plants blooming where none should have survived. Is it possible that life was guided, not by intention, but by feedback, as if the planet itself were editing its own future? If so, what does that say about us, the descendants of that rebooted world? Are we another layer in a cycle of forgetting and remembering? The conscious phase of a planet that dreams, burns, and heals itself across eons. Perhaps the real beginning of our story was not creation, but recovery. Not light, but silence. The kind of silence that still lingers at the edge of consciousness when the night is long and the wind sounds like distant surf. The breathing of a world that once burned and then learned to begin again. There are moments in Earth's history when the air itself seems to shimmer, as if the planet were dreaming. The Paleocene gave way to the Eocene not with an extinction, but with a fever. A surge of warmth that spread like a memory returning too quickly. Unexpected, uncontrolled, almost alive. Scientists call it the Paleocene-Eocene thermal maximum, but names have a way of taming what they describe. This was no gentle warming. It was a planetary delirium. Temperatures rose by more than 5 degrees across oceans and continents. The Arctic was green again, full of palms and crocodiles. The poles, which once slept beneath frost, became jungles. Ice vanished. Rain fell in endless cycles. In a few tens of thousands of years, a blink of cosmic time, the world became a greenhouse of dreams. The ocean floor released vast clouds of methane, a greenhouse gas 30 times stronger than carbon dioxide. But from where did it come? What loosened the seals of the deep? Some say it was volcanic, the slow exhalation of magma through cracks opened by drifting plates. Others suspect something stranger, a feedback between biology and catastrophe, where dying forests release the very gases that deepen their death. Still others whisper about orbital patterns, subtle tilts in Earth's dance that focus sunlight like a magnifying glass. The evidence, scattered in isotopes and deep-sea cores, tells us only that something immense and rapid happened. Too rapid for comfort, too precise for accident. At the bottom of the sea, microscopic foraminifera recorded it in their shells. Their chemistry changed overnight. Carbon isotopes dropped sharply, as if someone had erased half the carbon record. The event left a line so distinct that it marks the boundary between epochs, a scar of warmth in the planet's cold geological memory. It is here that many paleontologists begin to question the continuity of evolution. How did so many species appear and vanish within such a narrow window of time? Was this a burst of creation or an organized reset? In those fevered millennia, the world was ruled by light. Forests stretched to the poles. Monsoons fell on lands that had never known rain. The sea became acidic. Coral reefs dissolved, and fish adapted or perished in silence. Mammals, small and restless, seized their moment. Their bodies grew lighter, more agile, more experimental. Within this brief age, hoofed creatures learned to run, primates learned to climb, and whales began to listen again to the call of the sea. It was as if life were being rewritten, the script of existence edited under a new sun. And yet, deep within the sediments of that age, something does not fit. The rate of carbon release, reconstructed from isotope curves, implies a source too vast for any known process. To explain it, scientists proposed buried clathrates, frozen methane trapped beneath oceanic sediments, suddenly thawed. But even that cannot account for the magnitude. Some researchers, like Richard Zebe and James Zakos, have quietly noted that the models failed to match the data. The warming was not smooth. It pulsed, in waves, as if orchestrated. Could it be that the Earth itself was caught in resonance? A planetary frequency struck by an unknown force? Some have suggested cosmic influences, perhaps a passing cloud of interstellar dust altering the sun's light, or micro-impacts stirring methane reservoirs. Others dismiss such thoughts as speculation, but the discomfort remains. The PETM, as it is abbreviated, defies simple causality. It behaves like a dream, coherent in sensation, irrational in sequence. In the fossil layers that follow, we find the strange witnesses of this warmth. Early horses no larger than foxes, lemur-like primates crossing from continent to continent along tree-covered land bridges, vast flightless birds with predatory beaks. Even the insects grew monstrous. Dragonflies and ants of impossible size filled the humid air. It is tempting to see in them echoes of the carboniferous giants that once ruled before the dinosaurs. As though the Earth, feverish and unguarded, was remembering older patterns. But perhaps the most haunting evidence lies not in bones, but in absence. At the height of the PETM, entire oceanic ecosystems disappeared without leaving fossils. For several million years afterward, their record is blank. Did they vanish completely? Or did the chemistry of the ocean make their traces dissolve? When we drill into the seabed, there are layers where shells should be, but there is only clay, sterile, as if the sea itself had forgotten how to record. One core recovered from the Atlantic shows alternating bands of red and gray, each representing centuries. The transitions are abrupt, suggesting environmental oscillations no model can yet explain. What mechanism could make climate swing so fast, then stabilize again? Some hypothesize that these were feedback loops in the carbon cycle. Others quietly suggest intervention, not by intelligence, but by the Earth's own emergent systems, behaving almost as if aware. During this warmth, mammalian brains began to enlarge. The fossil record of early primates shows sudden changes in cranial capacity, in vision, in dexterity. Some evolutionary biologists link this to the complexity of tropical forests, the need to navigate multi-dimensional environments. But what if it was more than adaptation? Could extreme climate itself, with its volatility and sensory overload, have shaped consciousness, training life to anticipate chaos, to remember patterns, to imagine? The first dreams, perhaps, were born from survival, and as the fever burned, the continents drifted. India, still moving north, neared collision with Asia, pushing up the Himalayas, mountains that would one day redirect wind and monsoon, carving the very climate of our species' future. Antarctica drifted southward, isolating itself, beginning to freeze again. The dream would not last. All warmth is temporary, all delirium self-limiting. When the carbon levels finally fell, they did so faster than they had risen. In a geological instant, Earth cooled. The forests at the poles died. The ancient warmth receded into myth, leaving only chemical ghosts. Some sediments from that transition show something eerie. A thin layer of iridescent clay filled with microscopic glass spheres, tiny spherules formed by impacts or lightning. But there is no single crater, no event we can name. Was it many small collisions? Or a discharge from within? A planetary thunderstorm venting energy? We will never know. What we do know is that life carried the memory of that fever. The mammals that survived were lighter, faster, more intelligent. The climate had selected for resilience, for curiosity, for endurance. The Cenozoic world that followed, the world that would birth the ancestors of apes and humans, was shaped by this crucible of heat. If the dinosaurs died by fire, the mammals were born from fever. And perhaps that is why the human story, even now, feels haunted by warmth, by the craving for light, for control, for endless growth. We are the children of a planet that once burned itself awake. As the Eocene dawned, the air thickened with moisture and scent. Forests rose over continents that no longer remembered the sea. In their shade, creatures with forward-facing eyes began to dream in color. The world exhaled, cooled, and prepared for the next forgetting. And yet, there are traces of another spike in the record, smaller but distinct, as though the fever tried to return. What if it never truly left? What if every warm pulse, every strange anomaly in our own time is not new, but an echo? The planet remembering the shape of its own delirium. The dream ended, but the memory remained. And perhaps, in some quiet way, we are still living inside it. In every age that follows catastrophe, the Earth seems to dream bigger, as if overcompensating for what it has lost. The Eocene's fever gave birth to a pageant of impossible creatures, the kind that make scientists whisper the word anachronism. They look as if they belong to another timeline, a shadow world of giants and ghosts. There were birds that could not fly, but could crush bone with their beaks. Titanus wooleri in North America, Paraphysornis in Brazil, Brontornis in Patagonia, predators 2.5 meters tall, stalking open plains that had never known such hunters before. There were mammals shaped like relics of the reptilian past. Andrewsarchus, a wolf-faced behemoth the size of a rhinoceros, its lineage unclear. Perhaps descended from hoofed herbivores, perhaps from ancient carnivores of the sea. And there were whales that had not yet learned peace, Basilosaurus, serpentine and colossal. a mammal in form but reptile in spirit, ruling oceans that still glowed with warmth. The fossils of these beings confuse even the most methodical paleontologists. They seem transitional. But between what and what? Many appear suddenly in the record, without obvious ancestors, as though summoned from genetic echoes buried in the deep time of the planet. Some researchers, like Hans Thewissen, have traced the transformation of early whale precursors, Pachycetus, Ambulocetus, small, land-dwelling hunters that took to the water. But the sequence feels compressed, accelerated, as if evolution itself had been coerced. In less than 10 million years, land mammals became creatures fully at home in the abyss. Why the haste? What drove such a return to the element from which all life began? Perhaps this is the rhythm of the Earth's recovery. To oscillate, to experiment wildly after each collapse. Or perhaps there is something more deliberate, more patterned, in the way forms return and recombine. Could genetic memory linger like scent? Molecular hints that call old designs back into being when conditions resemble those of their ancestors. In the heat of the early Eocene, oxygen levels soared, and with them, metabolic possibilities. Bigger bodies, faster blood, sharper senses. Forests cloaked the world from equator to pole, and beneath their canopies, the drama of reinvention unfolded. In South America, isolated by seas, marsupials and ungulates evolved side by side into beasts both strange and familiar. In Africa, the ancestors of elephants and hippos explored swamps that shimmered under an eternal summer. Europe was an archipelago of green islands, each a laboratory of forms. Yet for all this diversity, something feels missing in the record. In layers that should contain gradual transitions, we find instead absences, intervals where evolution seems to have leapt forward, as though time itself had skipped a beat. These are called ghost lineages, inferred ancestors that must have existed to explain the later forms, but whose bones have not been found. It's as if entire chapters of the story were deleted. The official explanations are cautious. Erosion, incomplete fossilization, sampling bias. But some researchers have begun to wonder if there might be deeper causes, fluctuations not just in environment, but in the very mechanisms of heredity. Epigenetic shifts, viral insertions, transposons, molecular chaos that rewrites the code of life during moments of planetary stress. Perhaps these giants and chimeras were the side effects of a biosphere dreaming too vividly. Consider the Uintatherium, a creature that looked like a cross between a hippo and a horned dinosaur. Its skull heavy with bone knobs and ridges that served no clear purpose. Or Arsinoitherium, a distant relative of elephants with twin horns like a mythic bull, found in the Egyptian desert, where once there was sea. Their anatomies speak of exuberance, not efficiency. Evolution here seems intoxicated, sculpting for beauty, for strangeness, for memory. And among these colossal forms, something small but profound was stirring. The first true primates, tiny, nocturnal, large-eyed beings leaping among the branches. Their fingers lengthened, their vision sharpened, their brains quietly expanded. In them, perhaps, the earth was beginning to remember intelligence, to rebuild the faculty that could one day ask why. There's a certain poetry in that the same epoch which birthed the largest terrestrial mammals also nurtured the first glimmers of thought. In every age of giants, a small, almost invisible mind emerges, as if consciousness is the counterweight to size, the whisper to the roar. Still, the giants continued. In the oceans, Basilosaurus stretched up to 20 meters, with teeth adapted for hunting other whales. It was the apex of the warm seas. And yet, within a few million years, it too was gone. The record of its extinction is as puzzling as its appearance. The sediments show no catastrophe, no sudden shift. It simply disappears. One hypothesis suggests food scarcity. Another points to cooling seas. But some paleontologists note that Basilosaurus fossils often occur near coastal regions that were geologically unstable, areas where methane vents and undersea landslides once erupted. Could the very forces that birthed the Eocene warmth have ended it, sealing away the carbon again and dragging these creatures into oblivion? There's an unsettling symmetry in that thought, that the same pulse that creates also erases, that the planet's respiration, exhale of warmth, inhale of cold, determines who may exist. In this rhythm, extinction is not tragedy, but punctuation. As the Eocene wore on, the fever subsided. Global temperatures cooled, and the polar forests began to wither. Grasslands appeared, tentative at first, spreading from the edges of drying basins. The age of lush excess was ending. The giants would have to shrink or vanish. The next epoch would demand restraint. But before it faded, the Eocene left one last enigma. Across continents, from Wyoming to Mongolia, there are fossils of giant birds, mammals, and reptiles buried together in mixed assemblages, species that should never have met, trapped in floods or sudden burials. The sediments suggest flash events, maybe volcanic winters, maybe methane explosions. The isotopes hint at short, intense cold snaps interrupting the warmth. Was the Eocene as stable as we imagine? Or was it punctuated by smaller catastrophes we no longer recognize because the record has blurred them into averages? And beneath all this, a subtler mystery. Magnetostratigraphic records, the orientation of iron particles in ancient rocks, reveal that the planet's magnetic field reversed multiple times during the Eocene at intervals shorter than usual. Could these reversals, these shifts in Earth's invisible heartbeat, have triggered biological or climatic responses? Or were they consequences, signals of something deeper stirring beneath the crust? Every reversal leaves its trace, like a faint echo of polarity, a whispered remember from the core to the surface. Perhaps the giants, the whales, the titanic birds, all moved within that field, their bodies tuned to forces we can barely sense. When the field shifted, did they lose their compass, their equilibrium, their world? The more one studies the Eocene, the more it feels like a mirage, bright, lush, and unstable. A memory of abundance that ended without explanation. What remains are bones, scattered like punctuation marks in a sentence we can no longer read. And perhaps that is the real lesson of this forgotten age. That greatness is always temporary. That evolution builds monuments only to erase them. The shadows of giants are not reminders of what once was, but warnings of what must always end. In the fading warmth of the Eocene, as night returned to the poles and forests fell silent, a new rhythm began. Slower, cooler, more deliberate. From the ruins of grandeur, smaller creatures emerged, carrying fragments of that exuberant past in their blood. But if the giants were erased, what erased them? Was it time or design or something we still lack the language to name? The world was cooling, and with it, memory itself. Maps are lies we agree upon. The world you see today, its oceans, its continents, its edges, is only one version of Earth's memory, frozen mid-drift. Beneath the surface, there are ghosts of older worlds, submerged, fragmented, erased. The Cenozoic, so often imagined as an age of stability after the chaos of the dinosaurs, was in truth an age of continental amnesia, a time when land itself forgot where it belonged. When the Eocene giants still roamed, the Earth's crust was restless. The Tethys Sea, a vast warm ocean that once stretched from Morocco to Indonesia, was closing. Africa and India drifted northward, inch by inch, toward the Eurasian plate. In their collision, mountains rose that would one day shape human history: the Himalayas, the Alps, the Zagros. But in that upheaval, entire ecosystems vanished, buried beneath rising stone. Fossils from the Tethyan margins show tropical corals and marine shells now trapped atop mountains thousands of meters above sea level. The sea floor became sky. But what of the lands that sank? Geologists speak of Zealandia, an almost entirely submerged continent beneath the Pacific, a drowned land the size of India, whose highest peaks form New Zealand's islands today. For decades, it was dismissed as a myth of plate tectonics, until satellite gravity maps and deep drilling confirmed its crustal thickness: continental, not oceanic. Zealandia once stood tall, part of the ancient supercontinent Gondwana, before sinking below the waves during the Paleocene. How does a continent disappear without trace? Some suggest gradual subsidence, the thinning of crust stretched by tectonic stress. Others point to mantle plumes, vast upwellings of molten rock that can both raise and sink regions over millions of years. But there are anomalies. Sediment cores from the Tasman Sea contain terrestrial pollen from the Miocene, long after Zealandia should have been fully submerged. Trees that should not exist beneath the sea. Was part of it still above water far longer than we think? It's not the only one. South of India lies the fabled Kerguelen Plateau, a submerged volcanic continent larger than Western Europe. Once an island arc covered in forests, it now lies 2 kilometers under the Southern Ocean. Drill cores have yielded remnants of wood, soil, and ancient spores, proof of a vanished terrestrial world. Satellite images of its seabed reveal river channels still etched into stone. What drowned them? As Antarctica drifted south and began to freeze, global sea levels dropped, exposing coastal plains elsewhere. Yet in some regions, geological strata suggest the opposite: sudden submergence, as if the planet's balance shifted unevenly. The cause could be glacial rebound, mantle flow, or something subtler, a redistribution of mass that geophysicists still model with unease. It reminds one of myth, stories of land swallowed by sea, civilizations lost to the deep. Atlantis, Mu, Lemuria, names dismissed as fantasy, but perhaps built upon whispers of real tectonic trauma. Even conservative geology concedes that during the Cenozoic, coastlines migrated by hundreds of kilometers. Entire archipelagos rose and fell. Consider the Mediterranean. Before it became a sea, it was a desert basin during the Messinian salinity crisis, a vast depression where rivers carved canyons deeper than the Grand Canyon. Then, in a cataclysmic moment, the Atlantic broke through at Gibraltar, reflooding the basin in a torrent that may have lasted only months. A continental-scale waterfall, erasing all that had existed before. Every epoch carries its own erasures. But what makes these lost continents haunting is not only their physical disappearance, but their silence in the fossil record. If Zealandia, Kerguelen, or other vanished lands hosted complex ecosystems, where are their traces? Perhaps the record lies deep below the reach of drills, or perhaps the sediments were subducted, swallowed back into the mantle, taking their stories with them. It is unsettling to realize that our planet recycles memory. Its geology is not an archive but a palimpsest, each layer scraped, rewritten, blurred. There's another enigma. In magnetic reconstructions of the Cenozoic seafloor, lines of polarity reversal trace symmetrical stripes on either side of mid-ocean ridges. But near certain drowned plateaus, the pattern breaks, as if time itself skipped. Geophysicists call these quiet zones, intervals where no reversals are recorded. Were the magnetic flips irregular? Or did crust formed during those times simply vanish? Such absences trouble those who study Earth's chronology. Because if we cannot fully trace the ocean floor, then our sense of geological time, so precise, so confident, may rest on assumptions. What if the rhythm of plate motion, the pulse of subduction and eruption, is not steady, but punctuated by events of global reconfiguration? Some researchers have proposed the idea of true polar wander, entire shifts of the planet's crust relative to its rotational axis, tilting continents thousands of kilometers over millions of years. It sounds dramatic, but magnetic data hint at such episodes, especially around 50 million years ago. If the Earth itself can change its orientation, then coastlines, climates, and biomes would have transformed without leaving a clear cause. Could such movement explain myths of sudden floods, of suns rising where they had not before? In the Indian Ocean, the submerged Mascarene Plateau holds volcanic chains whose alignment defies standard hotspot theory. Some scientists suggest it might be remnants of a proto-continent torn apart as India raced north. Gravity anomalies in the crust support this. Denser rock beneath what should be light continental material. A puzzle with no resolution yet. Every discovery of a lost land invites the same unease. How much of Earth's history lies underwater, invisible? The fossil record we study is biased toward what remained above sea level, a temporary fraction of the total surface. If continents themselves can vanish, how certain can we be about evolution's continuity, about the true migration of life? It's a humbling thought, that beneath every ocean there might sleep another chapter of life, erased not by time, but by depth. The deep sea is not just a void, it's a vault. Sediments thicker than Everest's height conceal forests, rivers, climates we've never named. Some believe even traces of pre-human tool-like patterns lie within these strata, though such claims are contentious and mostly forgotten. Yet the idea persists that perhaps the human story, or something akin to it, is older than we think, buried beneath lost coastlines. In the late Miocene, when global cooling intensified, sea levels fell once again, revealing continental shelves and corridors between lands. Species migrated, mingled, hybridized, the world rearranging itself upon invisible scaffolds of the past. But the ghosts of drowned continents remained beneath them, their gravitational pull subtly warping ocean currents and tides. Even today, satellites detect anomalies, deep mass concentrations, or mascons, hinting at the bones of sunken continents still shaping our seas. When the Earth moves, it forgets. It erases not out of malice, but out of necessity. To remain alive, to circulate memory, every submerged ridge, every vanished landmass is a sentence crossed out in the planet's long autobiography. Perhaps that is why the ocean feels so ancient, so mournful. It carries the weight of every forgotten world. And when you stand by the shore, listening to the tide, maybe what you hear is not just water, but the murmur of continents that once were, whispering their unfinished stories through the waves. In every sea there is a memory of land. Every wave carries dust that once was soil. Every current drifts above the skeletons of forgotten continents. And yet, during the early and middle Cenozoic, life made an extraordinary decision. It turned back toward the oceans. The age of leviathans had begun. Whales, those immense and soulful beings we now associate with silence and song, were not born of the sea. They were mammals of the land, warm-blooded wanderers that once walked on hooves. The fossil trail begins in the riverbeds of Pakistan and Egypt. Pachycetus, with its amphibious body and dog-like skull. Ambulocetus, the so-called walking whale, capable of both swimming and walking, half crocodile, half mammal. Within only 10 million years, those hesitant forays became full surrender. The descendants of land dwellers transformed into Basilosaurus, a serpent-bodied titan that ruled the Eocene oceans. But this transition is more than biology. It is symbolism made flesh. For the first time since life crawled onto land, evolution reversed its direction. What called these creatures back into the deep? Some say it was climate, the cooling seas offering new prey, new refuge. Others hint at a deeper instinct, an echo of origin, as if the genome itself remembered the salt from which all life began. Could memory survive within flesh? Could evolution be more than random change? A kind of dream within DNA, yearning for its first home. Marine archaeologists studying early whale fossils found another enigma. The skulls of Basilosaurus are elongated, unlike any modern species. Their inner ears, however, are already adapted for hearing underwater. Perfectly. No gradual refinement, no intermediate forms. It is as though auditory evolution had leapt forward in a single invisible moment. The same leap appears in their balance organs, the semicircular canals that control motion. These creatures were born knowing how to move through the three-dimensional labyrinth of the ocean. How does instinct acquire new geometry so quickly? One fossil, discovered in Wadi al-Hitan, the Valley of the Whales in Egypt's western desert, preserves an entire Basilosaurus skeleton encircled by smaller whales, perhaps its young, perhaps its prey. Around them are fish bones, turtle shells, and shark teeth, a graveyard of abundance. The site, once an ancient sea, is now sand. When the wind moves through those dunes, it sings through the hollows of vertebrae. A hymn to the sea that vanished and the giants that no longer sing. The rise of whales coincided with another oceanic transformation, the rearrangement of currents. As Antarctica drifted into isolation, the first circumpolar current formed, a cold, perpetual flow that sealed the southern seas into frost. This redirected global circulation, changing everything from monsoon patterns to nutrient flows. The whales evolved with the currents, following invisible rivers of temperature and plankton. Some scientists suggest that their migrations, spanning thousands of kilometers, may have shaped ecosystems themselves, fertilizing the oceans with their waste, redistributing nutrients between hemispheres. Whales, in a way, became architects of marine life, and yet, the fossil record hints at another layer of mystery. During the Oligocene, around 33 million years ago, global temperatures dropped sharply. Ice caps expanded. Many early whale lineages vanished abruptly, replaced by entirely new forms: baleen whales, toothed whales, the ancestors of dolphins. In geological terms, the transition was instantaneous. But what triggered it? Sediment cores from that time reveal traces of volcanic ash, shifts in isotopic ratios, sudden ocean acidification. Some hypothesize a comet impact in the ocean, smaller than the one that ended the Cretaceous, but enough to disturb the chemistry of the seas. Others point to tectonic rearrangements, the opening of the Drake Passage, the closure of the Tethys, the birth of the modern Atlantic gyres. But one curious pattern persists. Every time oceanic gateways open or close, mass extinctions follow. It's as if the planet's bloodstream, when rerouted, demands sacrifice. Among these transformations, a strange fossil appears, Leviathan melvillei, named for the author of Moby Dick, a Miocene predator with a skull over 3 meters long, teeth the size of a human forearm. It hunted other whales, an apex among apexes. But unlike Basilosaurus, Leviathan possessed echolocation and enormous brain cavities, evidence of cognition. Its rivalry with the giant shark megalodon is legendary in paleontology. Two titans sharing the same seas, both vanishing as if erased together. No clear reason, no single event. Perhaps the cooling oceans withdrew their abundance. Perhaps giants simply cannot endure long ages of change. Some researchers believe the extinction of these leviathans coincided with shifts in Earth's magnetic field, influencing migratory behavior. Marine sediments from that era record reversed polarities, chaotic for thousands of years. Could whales, creatures who navigate partly by magnetism, have lost their bearings, wandering into lifeless waters, stranding themselves? In mass whale graveyards along ancient coastlines, skeletons lie oriented in the same direction, as though drawn by an invisible line. The ocean keeps such secrets well. Its memory is fluid, bones dissolve, layers are buried, and what remains becomes pattern, not evidence, but rhythm. Even now, modern whales sing across the globe, their songs structured like languages, evolving through cultural transmission. In their deep-frequency calls, some oceanographers detect faint resonances of the Earth itself, harmonics echoing through the thermocline. Could those vibrations be remnants of ancient communication, a continuity of sound from the age of leviathans? Perhaps that is why their presence moves us so deeply. Whales are more than animals. They are living metaphors of return. In them, evolution folded back upon itself, proving that progress is not always forward, that sometimes the only path is homeward. Their migration through the water column mirrors memory itself, descending into depth, rising again for breath, never escaping the cycle. There's an old Inuit belief that the spirits of drowned lands inhabit whales, their songs carrying the voices of the continents below. When a whale breaches, they say, it is the earth itself remembering the sun. Science may not confirm such poetry, but the resonance remains. In the shadow of these giants, smaller creatures thrived. Dolphins, seals, seabirds, all inheritors of a world stabilized by marine giants. But the balance was delicate. The Oligocene's cooling continued, transforming tropical seas into temperate ones. Coral reefs contracted, food webs tightened. The age of abundance yielded to the age of precision. Life became efficient, lean, strategic. The leviathans that survived adapted through intelligence rather than size, and yet, something about them feels ancient, not in age, but in essence. To watch a whale surface is to glimpse the persistence of an earlier planet, one that still dreams through them. They are time made visible, rising and sinking, reminding us that the boundary between epochs is not a line, but a tide. In the depths, where no light reaches, the Earth still hums with geothermal energy, with whispers of tectonic motion. Down there, perhaps, sleep the unrecorded descendants of those first whales, lineages unimagined, invisible. We do not know all that lives below 6,000 meters. The ocean floor remains less mapped than the moon. For all we know, some relic of that Eocene ocean still moves in the black silence, older than any myth, unseen by the species who once revered it. The surface has changed, the continents have moved, but the sea remains what it has always been, a mirror for what the planet hides. The age of leviathans was not just a chapter of life, but a moment of self-recognition when Earth, through its creatures, looked back into its own depths and remembered what it had been before memory began. And as the world cooled further, and the first grasses began to spread over land, the ocean grew quieter. The giants fell away, leaving only echoes. But the songs continued, faint, slow, infinite. The kind of sound you might almost hear if you listen closely, late at night, when the world is still. Every so often, the Earth breathes in a way that no one notices. Between the cold epochs and the extinctions, between the upheavals that make history easy to measure, there are intervals of quiet abundance. Soft, green pulses that leave almost no scars in the geological record. One such pulse came in the middle of the Miocene, around 16 million years ago, when the world warmed again. Not as violently as the Eocene fever, not as deadly as the Paleocene chaos, but in a subtler, stranger way. A warmth that seemed to arise from within. Scientists call it the Miocene climatic optimum, a name that sounds serene, like a balance achieved. Yet, when we look closer, it is full of contradictions. Ice at the poles nearly vanished, but glaciers in some mountain ranges advanced. Sea levels rose, yet certain basins dried. Tropical plants grew in Alaska, while deserts spread in Africa. Something about this warmth was uneven, as if the planet's pulse was irregular, beating faster in some regions, slower in others. Sediment cores drilled from the ocean floor tell conflicting stories. In one layer, foraminifera shells show high oxygen isotope ratios, cold water. In the very next, they signal heat. Fluctuations measured in decades, not millennia. But how could climate swing so quickly without external cause? Some blame volcanic CO2 from the Columbia River basalts, which erupted in waves during that period. Others suggest shifts in ocean circulation as the Tethys finally closed. And yet, even with all those explanations, something does not add up. In 2017, researchers from the University of Southampton examined deep-sea cores from the Indian Ocean and found anomalies in boron isotopes, chemical fingerprints of pH and carbon cycles. The data implied pulses of acidification and recovery far faster than models predict. It was as if the ocean was exhaling carbon, then drawing it back in, a self-regulating heartbeat. Could the biosphere itself have been part of the mechanism? Could forests, plankton, and soil microbes together act as a kind of planetary lung, stabilizing the atmosphere through unseen feedback loops? In those millions of years, Earth looked familiar and alien all at once. The first grasslands spread across continents, their roots binding soil and altering rainfall. The ancestors of elephants, camels, and horses roamed open plains. Apes diversified in Africa and Eurasia, moving between shrinking forests and new savannas. It was a golden age of mammals, but also the beginning of the long decline toward ice. For reasons we still do not understand, the warmth began to fade around 14 million years ago. Ice returned to Antarctica, quietly at first, then completely. Oxygen isotopes in marine fossils spike upward, colder seas. But there is no clear catastrophe in the record, no asteroid, no volcanic cataclysm. It is as if some invisible switch was flipped. In one paper, a group of geophysicists proposed a subtle change in Earth's orbit, a slight reduction in axial tilt that altered solar input enough to cool the poles. Another team suggested shifts in the position of continents, which rearranged the great conveyor belts of the ocean. And yet, hidden within this broader cooling, there were interruptions, short bursts of inexplicable warmth, lasting centuries, sometimes only decades. These are seen in pollen sequences, coral growth bands, and speleothems deep in limestone caves. No known cause fits their frequency. Some climatologists now refer to them as crypto-warm events. They appear like whispers, too brief for tectonics, too slow for seasonal change. What could make the planet flicker between climates like a candle in the wind? There's an unsettling possibility that the Earth's interior might not be as thermally isolated as we assume. Studies of helium isotopes show irregular leaks from mantle plumes coinciding with some of these events. as if heat were released through cracks we can't yet map. Could the planet's deep engine periodically vent energy to the surface, influencing global climate in ways we have mistaken for atmospheric phenomena? If so, then warmth itself may be part of a larger cycle, geological, not merely atmospheric. This hidden warmth left subtle marks on life. During the Miocene optimum, coral reefs expanded into new ranges, even as old reefs bleached and died elsewhere. Fossilized coral heads from the Pacific show growth rings of extraordinary width, sometimes double the modern rate, suggesting rapid calcification in saturated waters. But in some layers, those same corals show anomalies of strontium, indicating sudden stress, growth, collapse, growth again. The rhythm of contradiction. And in the forests of Eurasia, something astonishing happened. Apes that had been small and arboreal began to grow larger, more terrestrial. The ground beneath them was no longer permanent rainforest but mosaic, half open, half shadow. Fossils from Kenya, Turkey, and Germany show apes experimenting with new ways of moving. Knuckle walking, upright posture, powerful grips. The seeds of bipedalism, perhaps, born not in the savanna but in the confusion between forest and plain. Could it be that the hidden warmth, unstable, shifting, forced life to adapt not to climate, but to unpredictability itself? If so, then the Miocene was the training ground for the kind of intelligence that would later walk on two legs. An intelligence shaped not by abundance, but by fluctuation. Memory that learned to anticipate change. Yet even as life adapted, something deeper was eroding. The stability of the carbon cycle itself. Marine sediments from that era show declining carbonate compensation depths, meaning the ocean was becoming less efficient at storing carbon. The biosphere was aging. The engine that had sustained warmth began to slow. Some climate historians describe it as the planet's first exhaustion. But perhaps exhaustion is not failure. It is wisdom. The Earth had seen too many fevers. Maybe this hidden warmth was a controlled experiment, a balance point between chaos and calm. For several million years, the climate hovered there, stable enough for forests to spread, unstable enough to keep evolution alert. The perfect illusion of peace. We find remnants of that illusion in today's world. Buried soils rich in carbon, amber-sealing pollen from trees that no longer exist, isotopic ghosts of forgotten oceans. And within those layers, the fingerprints of stability that never truly was. The Miocene optimum is remembered as the calm before the cooling. But perhaps it was something else. The Earth's brief meditation before descent. When we imagine deep time, we picture violence, impacts, eruptions, extinctions. But maybe the most mysterious moments are the ones like this, when nothing seems to happen, yet everything changes. The quiet intervals when life rewrites its strategies, when the planet exhales in secret. And so, when the warmth finally waned, it left no monument, no catastrophe, only a subtle melancholy in the rocks, the kind that can only be felt, not measured. The forests began to thin, the air dried, and the horizon stretched wide. The age of lush equilibrium was ending. Ahead lay dust, wind, migration, the long rehearsal for the world we would eventually inherit. In that transition, a new kind of silence took hold. Not the silence after fire, but the silence before frost. When warmth fades, silence follows. The Middle Miocene's lush equilibrium gave way not to catastrophe, but to a slow and steady vanishing. The sound of rivers retreating, the hush of forests thinning leaf by leaf. The planet was changing again, this time not through fire or flood, but through thirst. Geologists call this long descent, The late Miocene aridification. It began quietly, like a slow exhale. Around 10 million years ago, the Earth tilted its face a little differently toward the sun. Antarctica grew its first true ice sheets. Global sea levels fell. The once humid air lost its softness, and clouds carried less rain inland. What had been jungle became woodland. What had been woodland became grass. And what had been grass began to turn to dust. At first, no one would have noticed. A few dry seasons too long, a few rivers too shallow. But over millennia, the shift became permanent. Dust from newly forming deserts began to drift across oceans. Fine particles that would later settle in deep sea cores as silent testimony. Pollen trapped in lake beds tells the same story. Trees giving way to shrubs, then to drought-tolerant grasses. The earth was drawing back its green veil. In Africa, the transformation was profound. The dense tropical forests that had stretched from coast to coast began to fragment, opening corridors of sunlight and space. For the apes who lived there, this was both crisis and opportunity. No longer surrounded by fruit-bearing canopies, some ventured out into the open. Fossils like Sahelanthropus chidensis and Aurorin tuganensis, found in sediments 7 million years old, show hints of upright posture, femurs shaped for balance rather than climbing. In the language of bones, the earth was whispering its command. Stand. But the great drying was not confined to Africa. Across Eurasia, the once mighty Paratethys Sea, a vast inland body of water stretching from Central Europe to Central Asia, began to shrink, leaving behind chains of saline lakes and marshes. Fossil fish trapped in gypsum deposits tell of waters growing brackish, then toxic, then gone. When the sea finally vanished, entire species of marine life vanished with it, leaving their outlines in salt. What we now call the Black Sea, the Caspian, the Aral. These are mere remnants of that vanished ocean, and still the air grew drier. In North America, the western interior seaway had long receded, leaving prairies in its wake. Herds of horses and camels roamed where once there were mangrove swamps. In South America, the Andean uplift changed the climate, trapping rain on one side of the mountains and creating deserts on the other. The Atacama, the driest desert on Earth, was born in those years, a landscape of absolute silence where no river ever found its end. To the casual observer, this was evolution's triumph. The spread of grassland supported vast herds of grazers, the ancestors of bison, antelope, elephants. Predators adapted too: saber-toothed cats, hyenas, wolves. But beneath that apparent abundance lay something fragile, a new dependence on rainfall patterns that could not be trusted. Grasslands thrive on instability. They burn easily. They recover quickly. They remember every drought. Scientists studying dust cores from the Atlantic have traced rhythmic pulses of aridity. 10,000 years of drought followed by brief centuries of respite. These oscillations correspond to changes in Earth's orbit, in the precession of its axis. The deserts pulse like lungs, expanding and contracting with cosmic rhythm. And yet, superimposed upon those natural cycles, there are anomalies. Abrupt episodes of dryness that do not fit orbital models. In some layers, dust flux triples without explanation. Could volcanic aerosols have disrupted rainfall? Could ocean currents have shifted suddenly? Or was the planet itself experimenting again, testing how life responds to deprivation? One of the strangest findings from this time comes from Spain. In the dry basins of the late Miocene, paleontologists discovered fossilized leaves of tropical plants interbedded with layers of salt. It should be impossible. Lush vegetation preserved beside evidence of evaporation. Some propose short-lived climate reversals. Others wonder if microclimates, isolated pockets of humidity, persisted even as the world dried. Nature resists uniformity. Even in desolation, it hides oasis. But the long trend was unmistakable. By 7 million years ago, deserts stretched across northern Africa and western Asia. The monsoons weakened. Winds carried dust across the Mediterranean into Europe, a rain of ochre that tinted ancient soils. The Earth's albedo increased, brighter land reflecting more sunlight, reinforcing the cooling. Feedback upon feedback. A planet learning restraint after its long indulgence in warmth. The consequences were psychological, if one dares use that word for the biosphere. The great mammals that had once defined the Miocene began to vanish. The tusked Dinotherium, the horned Chalicother, the massive Gomphotheres. Their bones lie in dry riverbeds, victims of thirst and hunger. But alongside extinction came invention. Small, fast species multiplied. Brains grew. Social behavior became a weapon against scarcity. Survival required memory, cooperation, planning. Perhaps intelligence, as we know it, is the child of drought. In Asia, similar pressures sculpted new landscapes. The steppes, vast rolling seas of grass that would one day feed empires. But in their infancy they were empty, haunted by dust storms and migrating herds. Geological records show a rise in loess, wind-blown silt accumulating in layers tens of meters thick. Each layer a breath of wind turned to stone. The Earth was literally recording its size. Even the oceans felt the change. With less rainfall and more erosion, rivers carried iron and nutrients into the sea, triggering blooms of plankton. These blooms drew down carbon dioxide, cooling the planet further. Life adjusting the thermostat of life. But cooling is also contraction, the closing of possibilities. By the end of the Miocene, the world's climate had settled into a pattern that would define the coming epoch. Alternating drought and ice, pulse and pause. Archaeologists who study the deep pre-human past sometimes speak of a bottleneck of consciousness. They mean that environmental stress compresses behavior, forcing new forms of perception. The Great Drying, with its relentless oscillations, may have been such a bottleneck. For the first time, creatures with hands, eyes, and memory faced a world that demanded foresight. It is not hard to imagine an ape standing at the edge of a fading forest, gazing across a sea of grass, feeling both fear and wonder. The first glimmer of the question that would one day define humanity. What happened here? And perhaps the Earth, too, was asking that question. For even in the silence of deserts, there are records of movement. Magnetic reversals frozen in sand grains, faint alignments that tell of the planet's shifting heart. The fields flipped again during this era, as if mirroring the instability above. The Great Drying was not a single event, but a transformation of mood. The planet had grown contemplative. It was learning the art of endurance. The fever of the Eocene had burned away. The lush calm of the Miocene had faded. Now came the age of adaptation, of scarcity, of minds that learned to see the horizon not as a border, but as a promise. And in the distance, beyond the dunes and the wind, a new catastrophe was waiting. One born not of fire or drought, but of salt. There are moments when the Earth seems to hold its breath. Moments when balance lasts just long enough for life to trust it again. And then, without warning, the world inhales and everything collapses. One such moment unfolded at the end of the Miocene, when the Mediterranean Sea, cradle of future civilizations, vanished. Not metaphorically, but physically. The ocean became a desert. Geologists call it the Messinian salinity crisis. The name sounds clinical, But the reality was surreal, an entire sea drying under the sun. Around 5.9 million years ago, something closed the narrow gateway at Gibraltar that connected the Atlantic to the Mediterranean. No one knows exactly why. Some point to tectonic uplift, others to a drop in global sea level as glaciers thickened in Antarctica. Whatever the cause, the result was unprecedented. Cut off from the ocean, the Mediterranean began to evaporate faster than rivers could replenish it. Within a few thousand years, its vast basin, deeper than the Grand Canyon, became a landscape of salt and heat. Imagine standing at what is now the coast of Italy or Greece and looking down not at waves, but at a shimmering plain stretching hundreds of kilometers. Rivers that once flowed into the sea now plunged over 1,000-meter cliffs, carving canyons so deep they remain buried beneath modern sediments. The Nile, the Rhone, the Ebro, all turned to waterfalls. In that abyssal valley, lakes of brine collected, surrounded by salt dunes and gypsum towers. Temperatures soared, air shimmered, mirages danced over the white expanse. This was not the Mediterranean we know. It was a wound in the planet. Drill cores taken from beneath the seafloor confirmed this vision. Beneath thick layers of modern mud lies a band of crystalline salt up to 2 kilometers thick. Embedded within it are fossils of tiny organisms that lived in hypersaline water. Evidence that life clung to existence in brine pools at the lowest depths. Some layers show rhythmic alternations of gypsum and shale, suggesting seasonal cycles of flooding and evaporation. Rain would fall. Rivers would trickle in. The basin would briefly fill, then dry again. A pulse of hope, followed by desolation. Scientists once thought this drying lasted hundreds of thousands of years. But newer data, drawn from magnetostratigraphy and microfossils, suggest the crisis may have occurred in multiple rapid pulses, separated by brief refloodings. The Mediterranean, it seems, did not die once, but many times. A sea caught in the act of disappearing, again and again. What did this mean for the creatures that lived around it? The evidence is fragmentary but haunting. Fossils from Spain and North Africa show mammals that once roamed temperate woodlands suddenly replaced by desert-adapted forms. Hippos and elephants gave way to gazelles, rodents, and small carnivores. Even the vegetation changed. Pollen records show abrupt transitions from forest to steppe within centuries. Life adapted with astonishing speed, or perished. Some scientists believe this ecological turmoil shaped the ancestors of early hominins. The shifting climates of North Africa during this period created a mosaic of habitats, alternating arid plains and wetter refuges. Populations of apes and monkeys became isolated, evolving separately. When the sea finally returned, those fragments of life were flung back together, carrying the seeds of new forms. Evolution through separation, reconnection, and shock. A pattern that would repeat across all of human prehistory. The deeper mystery, however, lies in the mechanism of the collapse. The Strait of Gibraltar, barely 14 kilometers wide, is a fragile hinge in Earth's architecture. A subtle shift in crustal movement, a regional uplift of a few hundred meters, and the ocean's doorway closes. Models suggest that once sealed, the basin would lose nearly a meter of water per year to evaporation. In less than 10,000 years, the sea would vanish. But some evidence points to a more rapid drawdown, perhaps as little as 1,000 years. To species living through it, it would not have felt geological. It would have felt biblical. At the nadir of the crisis, the basin lay several kilometers below global sea level, its floor dotted with lakes of brine fed by occasional inflow from rivers and groundwater. The pressure difference between that abyss and the Atlantic above was enormous. When the barrier finally broke, sometime around 533 million years ago, the result was a flood beyond comprehension. The Zanclean Deluge, as it's known, may have been the most violent event Earth's surface ever witnessed. Seismic surveys reveal massive erosional scars at the base of the Gibraltar Strait, channels tens of kilometers wide, carved by water moving faster than any river could flow. Estimates suggest the Atlantic poured into the basin at speeds exceeding 100 kilometers per hour, filling it in less than 2 years. Imagine the roar, the foam, the sunlight refracted through billions of tons of water cascading downward. The desert sea reborn in chaos. Somewhere in that event lies the origin of countless flood myths. The Sumerian deluge, Noah's Ark, Atlantis sinking beneath waves. The parallels are tempting, though separated by millions of years. Perhaps memory itself, passed through geological and cultural strata, retains fragments of cataclysms long forgotten. The Mediterranean's refilling ended the Miocene and began the Pliocene. A new epoch, a new balance. But the scars of the drying remain. Beneath today's blue water lies a labyrinth of ancient river valleys, salt deposits, and collapsed caverns. Seismic mapping shows vast voids still filled with supersaline water, pockets of heat and pressure trapped for millions of years. Occasionally, those pockets leak, creating strange hypersaline pools on the seafloor, toxic lakes within the sea, where life flickers in alien forms. Biologists studying these pools have found microbes that survive without oxygen, feeding on sulfur and methane, relics of the world that existed when the Mediterranean was dead. In their chemistry, we glimpse the persistence of memory. Even extinction leaves traces of adaptation. The collapse of Eden, then, was not just a geological event. It was a rehearsal for the cycles of death and rebirth that define Earth's history. A world of abundance, reduced to salt and dust, then drowned and made new. Each stage a lesson in impermanence, and yet, one cannot help but feel something symbolic in it. A foretelling. The same region that would one day cradle human civilization once experienced total desolation. The same strait through which our ancestors would sail was once the wound through which the ocean returned. It is as if the stage for history was purified by catastrophe before the actors arrived. Today, satellites trace subtle salinity gradients in the Mediterranean that still echo that ancient rhythm. The slow exchange of water through Gibraltar, the whisper of evaporation in the east. The sea remains restless, never quite stable, always remembering its own vanishing. Perhaps that is the secret buried beneath its calm surface, that paradise is not lost once, but repeatedly. And each time it returns, it carries a little more salt. Every age of warmth ends with a breath, a single, almost imperceptible whisper of cold that deepens until it becomes destiny. After the sea returned to the Mediterranean, the world seemed momentarily calm. But far to the south, Antarctica was quietly changing. Snow, once fleeting, began to linger. Ice sheets thickened, reflecting more sunlight into space. The planet, after millions of years of lush fever, exhaled. This was the beginning of the long decline. The slow birth of the ice ages. It began in pulses, not walls. Around 3.6 million years ago, the Pliocene world still looked deceptively green. But something subtle had shifted. The Isthmus of Panama rose from the ocean, sealing the flow between the Atlantic and the Pacific. The two great currents that once mixed their heat were now divided, forcing the Gulf Stream northward. Warm water reached higher latitudes, feeding storms, feeding snow. Paradoxically, warmth became the architect of ice, Geologists have traced this transition through tiny shells buried in the seafloor. Their oxygen isotopes record the breath of glaciers, growing, retreating, growing again. In some cores, the shift is so abrupt it looks artificial, a step change, a flick of a switch. Scientists model it in terms of carbon dioxide, ocean salinity, orbital cycles. But the closer we look, the less it obeys simple rules. Between the warmth of the Pliocene and the chill of the Pleistocene, there's a turbulence in data, as if the planet were caught between two identities, neither fully tropical nor fully frozen. The consequences were vast. Grasslands spread further, forests retreated, winds sharpened, and on the newly forming ice sheets, silence grew thick, a physical thing, dense and radiant. With each winter that lasted a little longer, the Earth's albedo increased, amplifying its own cooling. Volcanic dust trapped in early Antarctic ice shows faint traces of metals, iron, nickel, the fingerprints of meteorite showers. Could cosmic debris have played a role, reflecting sunlight, altering stratospheric chemistry? Or was this merely coincidence, the randomness of deep time dressed as cause? In this cooling world, the oceans began to pulse with new rhythms. The thermohaline circulation, the global conveyor belt, strengthened. Deep water formed in the North Atlantic for the first time in millions of years, driving oxygen into the abyss. The result was paradoxical beauty. Coral gardens in cold water, whales migrating with clockwork precision, upwellings of nutrient-rich currents that painted the seas with plankton blooms visible from space. It was as though life had learned to breathe with the ice, and yet, within that apparent balance, there were disturbances. Around 2.6 million years ago, the final step into the Ice Age came abruptly. Ice sheets surged outward from both poles, grinding mountains into dust. The Pleistocene had begun. The climate's rhythm shifted from random fluctuation to structured cycles. 41,000 years of cold, followed by brief interludes of warmth. The metronome of the planet had been reset. But what mechanism kept this rhythm so steady? Astronomers point to Milankovitch cycles, variations in Earth's orbit and tilt that modulate solar energy. The timing fits elegantly. Yet even these celestial explanations falter in detail. Some glaciations begin before the cycles predict, others lag centuries behind. It is as though another conductor, unseen, were adjusting the tempo. In those first glacial advances, vast herds migrated south, chased by the growing walls of ice. Mammoths and mastodons appeared, their woolly coats and curved tusks perfect adaptations to a new world of wind and light. Saber-toothed cats followed, as did early humans, though not yet our kind. In Africa, the cooling climate fractured ecosystems, isolating populations of apes into separate valleys and plateaus. One lineage began to walk fully upright. The pressure of ice and drought sculpted bone and mind together. What the ice took from one region, it gave to another. Exposed continental shelves connected islands, forming bridges of migration, corridors across Indonesia, Siberia, and the Americas. The globe was shrinking, its edges folding inward. Each glaciation was a rehearsal for motion, for exodus, for survival. But ice does not simply arrive. It speaks first in water. In sediments from that era, we find alternating bands of silt and clay, marking the annual melt of glaciers. Each band is a heartbeat of thaw and freeze, a language of rhythm. The cores drilled from Greenland reveal a pattern even stranger, sudden spikes of warmth in the midst of cold, called Dansgaard-Oeschger events. In a matter of decades, temperatures rose by 10 degrees, then fell again. No known orbital cycle moves that fast. Theories multiply. shifts in ocean currents, volcanic aerosols, solar fluctuations, even meteor impacts beneath the ice. But perhaps these bursts of warmth were something else. The planet's way of testing the limits of balance, of remembering its forgotten warmth. There are clues that some regions never fully froze. Beneath Antarctica's kilometers of ice, radar imaging has found ancient valleys, rivers, even possible forests entombed yet intact. Samples from subglacial lakes contain microbial life, not fossils, but the living descendants of ecosystems millions of years old. The ice is not merely a tomb, it is an archive. Within its layers are trapped the gases of vanished atmospheres, ancient air, still breathing faintly when released in laboratories. Each bubble a time capsule of sunlight filtered through other skies. And as the ice thickened, the sea withdrew. Global sea levels dropped more than 100 meters. Continental shelves became grasslands, estuaries turned to plains. Humanity's deep ancestors may have crossed those dry expanses, unaware that they were walking across the future floor of oceans. What did they feel standing under colder stars, watching the horizon sharpen in the frozen air? Did they sense, even dimly, that the world was contracting, gathering itself for something immense? Some paleoclimatologists argue that the Pleistocene was not a single ice age, but a system, a self-sustaining pattern of extremes. Ice sheets grew until they destabilized, then collapsed in torrents, triggering floods that carved valleys and sculpted continents. Each collapse reset the cycle. The Earth had learned a new kind of breathing. Deep, cold, cyclical. It is strange to think that this icy discipline, this rhythm of destruction and renewal, prepared the world for us. Without it, the grasslands where our ancestors learned to think might never have existed. Without it, the fluctuations that tested memory and cooperation might never have refined consciousness. The ice was not the enemy of life, but its tutor. Yet beneath that philosophy lies something more unsettling. In Greenland's oldest ice layers, researchers have found particles of soot, traces of fire, from sources too large to be volcanic. Some date back more than 3 million years. Could natural wildfires alone explain such concentrations? Or do they point to forces we no longer recognize? Electrical storms, cosmic influxes, magnetic discharges from the poles. The ice remembers more than it reveals. Each glacier is a slow witness, its surface flowing even as its depths remain still. To walk upon one is to step on time itself, compressed and translucent. The air above feels ancient, stripped of sound. And if you listen carefully, beneath the crack and groan of shifting ice, you might hear something like breath, the exhalation of the planet between epochs. The ice breath continues even now, faint but persistent. Though our age feels warm, the memory of frost lies beneath it, waiting. The Earth does not forget easily. Its lungs of ice inhale slowly, over tens of millennia. And when they exhale, continents remember their shape. Somewhere within that frozen rhythm, perhaps, lies the secret of all cycles, that every warmth contains the seed of its own cold, and every frost remembers the light it once reflected. The ice had not come to destroy, it had come to erase. What it left behind was not ruin, but absence, an emptiness that deepened with each returning cycle of cold and thaw. The Pleistocene world was full of life, yet haunted by loss. Whole lineages of giants, creatures that had walked beside early humans, simply vanished. One by one, the great mammals went silent, leaving their bones to bleach under a sun that no longer seemed as bright. We call it the Quaternary extinction, though its meaning feels too clinical for the scale of its grief. Between 50,000 and 10,000 years ago, More than half of all large land animals disappeared. Mammoths and mastodons, saber-toothed cats, woolly rhinoceroses, cave bears, giant ground sloths, the short-faced bear of America, the marsupial lions of Australia. For 200,000 years they had survived ice and fire, but now they fell together, almost in unison, across continents. Science debates the causes: human hunting, climate instability, disease, or perhaps something still unmeasured. But the pattern is strange. The extinctions were not simultaneous. In some regions, they began long before humans arrived. In others, species persisted for millennia after contact. The timing feels patterned, as if governed by a pulse beneath the surface, a rhythm of vanishing written into the planet's metabolism. The ice was receding, yes, but unevenly. Vast meltwater lakes formed and burst, sending floods across continents. The air filled with steam, then dust. Ecosystems blinked in and out of existence like candle flames. To survive such turbulence required adaptability, memory, strategy, the very qualities that define the emerging human mind. But the larger animals, bound to slower rhythms, could not keep pace with a world that no longer stayed still. Still, the evidence resists finality. In caves across Europe and Siberia, archaeologists have found bones of mammoths bearing marks of both age and healing, proof that they lived long after their supposed extinction. In some Arctic peatlands, isolated populations may have survived into the Bronze Age, their breath steaming under auroras seen by our ancestors. If extinction is supposed to be final, what does it mean when the dead linger in fragments, half alive in forgotten corners of the world? Perhaps extinction, like memory, fades by degrees. Even now, the land carries scars of their absence. Beneath the tundra, frozen soils hold DNA of vanished species, preserved in ice as if waiting for recall. Geneticists have sequenced fragments from these samples, finding ghost lineages that do not match any known animal. Could there have been branches of life entirely lost to record? Species that left no skeleton, only whispers in genomes? It seems the Earth hides not only fossils, but memories written in code. Some scientists have begun to suspect that the final pulse of extinction may not have been solely biological. Around 12,900 years ago, the Younger Dryas began, a sudden return to glacial cold just as the world was thawing. In Greenland's ice cores, a thin layer of platinum appears, matching patterns of cosmic debris found on multiple continents. Firestorm sediments, nanodiamonds, microspherules, traces that suggest an impact or a swarm of impacts, perhaps from a fragmented comet. The hypothesis is controversial, yet whether celestial or terrestrial, something ignited. Charcoal layers from that time are thick, global, and abrupt. Forests burned. Megafauna collapsed. The Clovis culture in North America, one of humanity's earliest organized societies, nearly vanished. It was as though the planet itself had paused mid-recovery, its breath caught in sudden frost. When warmth returned once more, the giants were gone. Only their shadows remained, carved into myth. In every early civilization, echoes of them appear. The aurochs turn to sacred bull, the mammoth to the thunder beast, the great sloth to the forest spirit. The human imagination became the final refuge of species the earth no longer held. And yet, in that silence, humanity found itself. Without the giants to dominate the plains, humans became the new architects of ecosystems. Fire replaced tusks, tools replaced claws. The world, emptied of competitors, became a mirror. For the first time, we saw our reflection in its stillness, but the earth remembers differently. Geological strata record a faint but measurable shift in atmospheric composition around this time. A small rise in carbon dioxide, perhaps from burning forests, perhaps from thawing soils. Even extinction has chemistry. When great herds vanish, the carbon locked in their bodies returns to the air. The very act of disappearance alters the climate that follows. Some paleoclimatologists describe the Pleistocene-Holocene boundary as a soft apocalypse. There was no single event, only a series of diminishments. A species here, a river there, a continent's worth of sound fading away. If one could travel backward and listen, the difference would not be visual but auditory. The diminishing thunder of hooves, the quieting of breath across plains. The world became more silent, and in that silence, consciousness grew louder. Even the ice seemed to retreat in sympathy. Glaciers melted into rivers, rivers carved valleys, valleys became the fertile grounds of agriculture. In this new landscape, the memory of cold lingered like a warning. The first humans to settle the Near East built shrines to stone animals long gone. Lions, bears, leopards, aurochs, guardians of a vanished Eden. They carved them not out of nostalgia, but reverence. To remember, they realized, was a form of survival, yet not all was known. The cause of the Younger Dryas cooling remains a riddle. Recent oceanic studies suggest sudden discharges of fresh water from glacial lakes into the North Atlantic, disrupting circulation. But ice core chemistry reveals something deeper. Spikes in beryllium-10, a tracer of cosmic radiation. The timing aligns with magnetic field instability. Could solar storms, impacts, and geomagnetic shifts have acted together? A chorus of disruptions rather than one catastrophe. If so, extinction itself might have been orchestrated by resonance, Earth responding to multiple frequencies of stress at once. In the end, what perished were not just species, but ways of being. The great mammals lived in cycles measured by centuries. Humans began to live by seasons. The Ice Age had taught them that change was no longer background noise. It was the medium of existence. And so, when the last mammoth fell and the last saber-tooth slept in the permafrost, a strange inheritance began. Humanity emerged not as ruler, but as witness. The last animal who could remember. Perhaps that is why, deep in our psychology, extinction still terrifies us. We are its children. We carry within us the memory of vanishing, passed through genes and dreams alike. The ache we feel when a species disappears today is older than civilization. It is the echo of those first silences, when the world dimmed and we realized that we were alone. The ice breath had sculpted the stage, and now its players were gone. But the silence it left behind would not remain empty for long. The thaw was coming. The rivers were rising. And somewhere in the fertile mud of the new world, new minds were forming. Eyes bright, hands restless, hearts already reaching for the lost. When the last mammoth fell and the tundra grew quiet, something else began to stir. A new presence, smaller in body but larger in intention. The age of disappearances had ended, but its silence did not fade. Into that silence stepped humanity, and the earth, as if recognizing an echo of itself, began to change again. In the layers of sediment that mark this transition, archaeologists find not catastrophe, but precision. Flint, obsidian, shaped bone. Each tool, each carved mark, a declaration that memory could be externalized. Before this, nature had recorded her own story in stone and ice. Now, a creature had appeared who could write her narrative for her. The planet's voice had acquired syntax. The earliest traces of this mind appear in Africa, in the Olduvai Gorge, in the Awash Valley, in the shadows of Mount Kilimanjaro. Here, the bones of Australopithecus and Homo habilis lie interwoven with the tools they made. Their faces are halfway between animal and idea. They carried the first sparks of abstraction, the capacity to shape what did not yet exist. But behind their ingenuity was something more haunting, a strange awareness of time. Stone tools endure for hundreds of thousands of years, but the beings who made them did not. Each hand that struck flint against core belonged to someone who lived, suffered, dreamed, and vanished. Yet the pattern of their work remained. It is as if the planet began to remember itself through us, to continue its own long narrative of creation and erasure. But now, through consciousness, the Earth was cooling further, the glacial breath still rhythmically inhaling and exhaling across the continents. Forests receded, savannas spread. The apes who had once hidden in canopies now walked open ground. In that exposure, something shifted. Vision became depth. Hands, freed from the need to climb, began to gesture, to plan, to imagine. The body straightened, and along with it, thought. The horizon, once a boundary, became invitation. But the fossil record of our evolution is less a ladder than a mosaic. Australopithecus afarensis in Ethiopia, Homo erectus in Java, Homo naledi in South Africa. Fragments of a story that refuses to resolve. Some species overlap for hundreds of thousands of years, as though parallel experiments were running simultaneously. The neat linear march from ape to human never existed. Evolution, like the planet itself, prefers complexity to clarity. Even more unsettling are the anomalies. Skull fragments found in Dmanisi, Georgia, show features of both early and later humans, as if two chapters had merged. Tools in India and Arabia predate the migrations that supposedly brought them there. In Siberia, the Denisovans, a mysterious branch of humanity known mostly from DNA, appear suddenly in the record, then disappear just as suddenly, leaving traces of their genome in us. Each discovery expands the map and simultaneously erases its borders. It is as if humanity was not a single lineage, but a convergence, multiple experiments in awareness coalescing into one persistent shadow. By the time Homo erectus mastered fire, something irreversible had begun. Fire extended daylight, warded off predators, altered diet, and most importantly, it changed perception. The flickering of flames mirrored the flickering of thought, transient, self-aware, recursive. Around the firelight, faces became visible at night, expressions readable, stories speakable. The first myths may have been told as the wind hummed through the grasslands of East Africa, the sky filled with unfamiliar stars. In that light, we learned to see ourselves reflected in the eyes of others. Consciousness, once a private phenomenon, became shared. The human mind became social, and through that sharing, civilization began. Not in temples or cities, but in murmurs beside fire. But where there is light, there is also shadow. With awareness came fear, of death, of loss, of memory itself. We began to bury our dead, to decorate them, to leave offerings. At first this seems tender, but perhaps it was defensive, an attempt to soften the incomprehensible. The first graves are not monuments to life, but negotiations with oblivion. It's here, at this threshold, that history as we know it begins. The transformation of natural rhythm into narrative control. We ceased to be mere observers of the planet's cycles and became participants, even manipulators. We shaped stone, tamed flame, and eventually, the animals that once ruled us. Yet beneath that triumph lies the echo of the great extinctions that preceded us. On some level, perhaps we always knew the world had been emptied to make room for our story. Recent genetic evidence suggests that all living humans descend from a small population, perhaps as few as a few thousand individuals, who survived a climatic bottleneck around 70,000 years ago. Some link it to the eruption of Mount Toba in Indonesia, whose ash covered the skies, dimming the sun for years. Others see it as another oscillation in the planet's endless breathing. Whatever the cause, that near extinction left a mark on us deeper than genes. It taught the mind to fear scarcity, to cling to control. After the bottleneck, expansion was unstoppable. Humans spread across Asia, Europe, Australia. Each migration carried not only tools, but memories, encoded in language, gesture, song. The earth that had once sculpted us now became the canvas for our will. Caves filled with images of bison, mammoth, and horse. Art not as decoration, but as invocation. To paint an animal was to remember it, to keep it from disappearing completely. Even as we became dominant, we continued to live in dialogue with absence. There's an ancient paradox here, that the more humans remembered, the more the planet seemed to forget. Forests cleared, soils eroded, species vanished. Our memory required the Earth's amnesia. Civilization's light cast an ever longer shadow. Yet in those early millennia, we were still close enough to the Earth's breath to feel its pulse. In the rhythmic migrations of herds, the rise and fall of rivers, the tilt of constellations, our ancestors read meaning. They did not separate spirit from nature or time from season. Each dawn was a continuation, not a beginning. Perhaps that intimacy was temporary, the last moment before abstraction severed us from the living planet. The Neolithic would soon come, and with it, agriculture, architecture, and history proper. But for now, the world remained alive in every stone and wind. The human shadow was long but still gentle. Even now, when we walk at night and feel the pull of the stars, we are answering that ancient alignment. The body remembering the age when it first learned to stand beneath the cold sky, when survival meant attunement, not conquest. The earth had shaped us from its dust and breath, and in return, we offered it reflection. It is strange to think that awareness itself might be the planet's defense against forgetting, a way for Earth to remember its own story through us. But if that is true, then every discovery, every word, every act of creation is also an echo of loss. For every shadow must belong to a light, and every human step casts both. The story of humanity, as we tell it, begins with memory carved into stone. Sumer, Egypt, the Indus, the valleys of China. But deep beneath those names, in layers that time has blurred, there are whispers of something older. Not in myth alone, but in sediment, in architecture that should not exist, in dates that refuse to fit the sequence. The Earth has always kept secrets, but some of them look uncomfortably like us. Archaeologists once believed civilization began about 6,000 years ago. When writing appeared, cities rose, and agriculture matured. But that timeline has grown porous. In 1994, on a wind-blown hill in southeastern Turkey, a shepherd stumbled upon carved stones protruding from the earth. Excavations revealed a vast complex of megaliths, concentric circles of limestone pillars, each etched with animals and symbols. Its name, Göbekli Tepe. Its age, 11,600 years. Thousands of years before the wheel, before metal, before known agriculture. The site defied logic. It was built by hunter-gatherers who should not have had the means to organize such construction. Each pillar weighs 10 to 20 tons. There are no traces of permanent habitation nearby, only the monument itself, as though built not for living, but for remembering. After centuries of use, it was deliberately buried. Not destroyed, not eroded, but entombed under tons of soil, as if hidden from the future. What could they have been commemorating? Some researchers connect Göbekli Tepe's date with the end of the Younger Dryas, that mysterious cold snap 13,000 years ago, when the last glaciers melted and the sea rose in sudden violence. Could it have been a memorial to survival, or to something lost? The carvings of vultures and headless men suggest ritual remembrance. Others see astronomical alignments, the pillars oriented to the rising of certain stars that no longer match today's sky. If so, the builders were not only engineers, but astronomers. And Göbekli Tepe is not alone. Beneath the waters off India's Gulf of Khambat lie the outlines of what appear to be city streets, walls, and foundations, dated by sonar and retrieved artifacts to nearly 9,000 years ago. In Japan, the submerged site of Yonaguni, a stepped stone structure descending into the sea, has long divided scholars. Natural formation or human-made monument drowned when sea levels rose after the Ice Age. There is no consensus. But the symmetry of its terraces, the sharp angles of its corridors, make coincidence difficult to believe. Even on land, clues multiply. In the Sahara, beneath the sand, satellite imagery reveals geometric anomalies, vast rectangles and circles, buried under dunes that were once fertile plains. In the Amazon, LIDAR scanning has uncovered networks of ancient earthworks and roads, suggesting dense human occupation long before European contact. We are discovering that civilization is not a sudden flame, but a series of sparks. Some extinguished, some hidden, some perhaps waiting to be seen again. Yet mainstream timelines resist revision. To acknowledge an advanced pre-Neolithic culture would mean rewriting not just history, but prehistory, reconsidering how memory survives catastrophe. Could entire societies have risen, flourished, and fallen during the unstable millennia between the Ice Age and the first known empires? The pattern would fit the Earth's rhythm: growth, collapse, forgetting, rebirth. There is evidence, not proof, but suggestion, of such amnesia. Around the world, flood myths share uncanny details: a sudden deluge, a chosen remnant, a forbidden knowledge preserved. Mesopotamia's Utnapishtim, India's Manu, the Hebrew Noah, the Andean Unu Pachacuti. Stories separated by oceans but united in structure. Were these coincidences of imagination, or cultural memories of real sea level rise when the glaciers melted and coastlines drowned? The ocean itself hides the answer, for more than 20 million square kilometers of ancient continental shelf now lie underwater. The first villages, the first temples, may sleep there still. Geology supports the scale of that transformation. Between 15,000 and 7,000 years ago, sea levels rose more than 100 meters. Islands became peaks, peninsulas became archipelagos, continents fractured. If humans had settled along Ice Age coasts, as logic suggests, for water was life, their traces would now lie beneath silt and tide, invisible to our archaeology. What we call prehistory may simply be history that sank. A few independent scholars like Graham Hancock and Paul Laviolette have argued for cycles of forgotten civilization, triggered by global cataclysms. Their ideas are controversial, often dismissed as pseudoscience, yet even their critics admit the gaps are real. The sudden appearance of agriculture in multiple regions around 10,000 years ago, the unexplained precision of early astronomy, the inexplicable loss of earlier tool traditions, all hint at knowledge interrupted, then rediscovered. Consider agriculture itself. Genetic studies of wheat and barley show domestication around the same time in distant regions, as if coordinated. The same with rice, maize, and millet. Did humanity simply converge by chance? Or did scattered survivors of a prior culture carry fragments of technique, passing them on like myths? If so, then what we call the dawn of civilization may have been a reconstruction, not the beginning of knowledge, but its restoration after erasure. Some archaeologists propose that global trauma at the end of the Ice Age, floods, climate chaos, magnetic storms, erased entire chapters of culture. Those who survived retreated inland, rebuilding with what memory remained. Over millennia, that memory became legend, and legend became myth. The Atlantis of Plato, the sunken land of Kumari Kandam, the drowned cities of the Pacific. Each might be the same wound, seen from different shores. But whether these lost civilizations existed or not, their idea serves a deeper truth. We are haunted by the intuition that history is incomplete, that the line of progress we draw from caves to satellites skips unnamed peaks. It may not be conspiracy that hides them, but entropy, the natural forgetting of a planet that reuses its own past. Even so, fragments survive, not in stone, but in proportion. The geometry of early monuments across continents shares strange harmonies. The 52-degree slope of pyramids in Egypt, Mexico, and China. The alignment of ancient structures to solstices. The recurring use of sacred ratios like 3-4-5. Were these coincidences or echoes of an earlier aesthetic preserved through cultural DNA? Göbekli Tepe, Yonaguni, Kambat, the lost plains of Doggerland beneath the North Sea. These are not proof, but questions. They remind us that the boundary between myth and evidence is as fragile as the crust of the earth itself. Perhaps the first civilizations were not lost to time, but absorbed into it. Their materials weathered, their myths repurposed, their bones reassembled into ours. The earth does not erase, it recycles. And if memory is cyclical, then maybe we are not the first beings to look backward, wondering what came before. Maybe each epoch breeds its own archaeologists, each convinced it stands at the beginning, unaware that it is merely the middle of another forgotten age. What remains of them lies beneath our feet. Carved stone, drowned ruins, magnetic whispers in the rock, waiting for another civilization, someday, to find us and ask the same question. What came before you? There are fractures in history where even the planet seems to hesitate. Pauses where memory itself feels damaged, like a page scorched and half rewritten. The end of the last ice age was one of them. A moment when the earth thawed too fast, when rivers flooded continents, and when something, no one knows what, interrupted the rhythm of the world. Scientists call it the Younger Dryas. But in older tongues, it was remembered simply as the long return of winter. It began around 12,900 years ago. The planet had been warming steadily for millennia, glaciers retreating, sea levels rising. Mammoths wandered shrinking tundras, and humans followed them, carrying fire and stone into new lands. Then suddenly, warmth stopped. Temperatures plummeted within decades, a geological blink. In Greenland's ice cores, the shift is as sharp as a knife. Oxygen isotopes fall, methane drops, dust increases. Something immense had happened, something fast. What could halt a global thaw overnight? The most accepted theory speaks of water. As the North American ice sheets melted, a vast lake, Lake Agassiz, formed across Canada. When its ice dam collapsed, trillions of tons of fresh water rushed into the North Atlantic, disrupting ocean currents. The Gulf Stream faltered. The world shivered. But the math is uneasy. The timing does not fit perfectly. Some sites cooled earlier, some later. And in the sediment, other anomalies appear. Traces of platinum, nanodiamonds, microspherules melted by unimaginable heat. An alternate theory emerged. Impact. Not a single comet, but a shower. Fragments from a disintegrating body that rained over the northern hemisphere, igniting forests and vaporizing ice. Fire before frost. The evidence is circumstantial but haunting. Charcoal layers in North America, Europe, and the Middle East all date to the same horizon. Beneath them lie the bones of species that never rose again. The timing coincides eerily with the disappearance of the Clovis people, the first known culture in North America. Their tools end abruptly. Their symbols vanish. Yet the idea of an impact divides scholars. Many argue the debris could come from volcanic eruptions or from processes we don't yet understand. Still, the imagery is irresistible. A celestial spark falling into the wound of the earth, resetting climate, erasing memory. It fits a pattern older than science. The pattern of destruction followed by renewal. Whatever the cause, the Younger Dryas lasted more than 1,000 years. Glaciers returned to Europe. The deserts of the Near East grew cold and dry. Lakes shrank, rivers slowed. And in that harshness, something paradoxical happened. Humans began to settle. The first experiments in agriculture, once impossible in the fertile chaos of the melt, began precisely in this age of deprivation. In the Levant, the Natufian culture built permanent stone houses, harvested wild grains, and buried their dead beneath floors. When the ice relaxed again, they were ready. Civilization waited for scarcity to teach it discipline. But the Younger Dryas is not just a story of climate. It is a story of broken continuity. The archaeological record around that time shows interruptions in trade routes, abandoned caves, tool traditions vanishing mid-generation. The Earth's memory faltered. Sites that should connect, from Syria to Anatolia, from the Danube to the Indus, do not align. It's as though an invisible curtain fell between eras. Some geologists see this rupture in the ice itself. At the base of certain glaciers, thin layers of gray clay mark sudden melts, then refreezing, like pages smudged in the Book of Climate. The pattern repeats in Antarctica, even though it lies half a world away. Synchronization across hemispheres, faster than air could carry, faster than ocean currents could flow. What signal could reach both poles at once? Solar radiation, a magnetic shift, the planet answering to a voice beyond itself. Recent studies of ice core chemistry reveal spikes in beryllium-10 and chlorine-36, isotopes formed by cosmic rays. They suggest a sudden increase in radiation from space, perhaps a solar outburst or the passing of the solar system through a dense cloud of interstellar dust. For a time, sunlight may have dimmed, the upper atmosphere ionized. The night sky would have glowed with auroras seen even at the equator. Imagine our ancestors looking up at a red, trembling firmament, the air humming with static. They would have thought the gods were speaking. Perhaps they were right, in a way, and as the cold deepened, humanity adapted again. In caves and valleys, art changed. Before the Younger Dryas, the walls of Europe were filled with animals, bison, horses, mammoths, painted with tenderness. Afterward, figures grew abstract, spirals, lattices, stars. Some of these symbols resemble patterns produced by plasma discharges and magnetic fields. Could it be that people recorded what they saw in the sky? The auroral storms of a restless sun. The same motifs appear thousands of kilometers apart, from Lascaux to Australia. Coincidence or shared witness? When warmth returned once more, it did so violently. Around 11,600 years ago, temperatures spiked again. Sea levels surged by meters. The world drowned its ice, In that flood, the coastlines of the Ice Age vanished. The plains that once joined continents became seabed. Doggerland, between Britain and Europe, slipped beneath waves. The Persian Gulf flooded. The Sunda Shelf, once a vast land connecting Southeast Asia, disappeared. Every ancient culture that followed carried a story of a deluge. Some see this date, 11,600 years ago, as the true boundary between prehistory and history. It is also the exact age Plato gave for the fall of Atlantis. Coincidence again, perhaps. Yet something undeniably changed then. Stability returned. The Holocene began. And the memory of the ice receded into myth. But memory never vanishes completely. In Greenland's layers, even now, scientists can trace the pulse of that chaos. Annual bands thinner than a hair, alternating between dust and clarity, warmth and cold. Each represents a year when something survived, and something did not. The ice remembers for us what we cannot hold in mind, that the world we live in is borrowed time, reprieve between extremes. We like to imagine history as linear, progress unfolding in light, but the Earth's history moves in loops, each cycle erasing and reteaching. Perhaps civilization itself is a byproduct of forgetting, an attempt to rebuild what the ice took away. There's an unsettling symmetry in the numbers. The Younger Dryas ended about 11,600 years ago. The last major glaciation before it ended roughly 120,000 years earlier, nearly the same interval. Some climatologists whisper that the rhythm might repeat. A hidden clock in the solar system's motion, or in the planet's magnetic core that resets climate in beats of 100 millennia. We do not yet know the mechanism. We only know that the last great thaw made us, and the next one could unmake us. Standing atop a glacier today, one can feel the paradox. Ice that seems eternal, yet moves every moment, groaning beneath its own weight. It is the closest thing the Earth has to thought. Slow, vast, recursive. The ice remembers, even when we forget. And perhaps that is what the Younger Dryas truly was. Not punishment, not accident, but recollection. The planet remembering itself through frost, rewriting its own memory after too much warmth. The question is not whether it will happen again, but whether this time we will recognize it when it begins. When the ice finally withdrew and the air softened, the world was reborn. Rivers flooded with meltwater, plains turned green again, and for a brief instant, in geological terms, the planet felt young. The Holocene had begun. But within that new light, humanity did something unprecedented. It began to rewrite the story of creation. The first seeds were not planted in soil, but in memory. After the Younger Dryas, the survivors of countless small tribes began to gather. They had endured the cold, the floods, and the silence of the vanished beasts. Perhaps they carried with them stories of warmth lost and regained, of skies that burned and seas that rose. Out of that trauma came a need for continuity, for narrative order. We call it civilization. But in truth, it was a recovery project, a reconstruction of what the earth and the mind had both forgotten. In the Fertile Crescent, on the edges of ancient lakes that no longer exist, humans learned to tame wild grains. They domesticated animals, built permanent dwellings, and began to mark the passage of time with purpose. It is no coincidence that agriculture emerged almost simultaneously in other places, China, the Andes, Mesoamerica, as if the same invisible command had been issued across the world. Some scientists speak of climate stabilization, others of necessity. But perhaps it was something subtler, the collective instinct to anchor the world again, to fix the flow of time after millennia of instability. Yet even as humans cultivated the land, they also began cultivating myth, a different kind of soil. In every early civilization, from Mesopotamia to the Nile, from the Indus to the Yangtze, creation stories appeared that sound less like beginnings and more like recoveries. The gods do not create the world from nothing. They restore order after flood or chaos. The earth is remade from fragments of what came before. The divine act is not invention, but remembrance. In Sumerian tablets, among the oldest written words, the god Enki rebuilds a broken world drowned by water. In Egyptian myth, Ra rises from a primordial ocean, standing on the mound of the first land to reappear after deluge. The Maya tell of previous ages destroyed by fire and water before ours began. Even Genesis speaks not of a void, but of a world already existing, covered by water, waiting to be spoken into shape again. The pattern is unmistakable: creation as restoration, knowledge as recovery. Archaeologists find fragments that seem to echo those myths in the material world. Stone circles older than writing aligned precisely to solstices. Star maps carved in caves that match skies tens of thousands of years gone. Sites like Nabta Playa in Egypt's desert, a calendar of megaliths dating to before the pyramids, suggest that astronomy was among humanity's first sciences. But why such obsession with the heavens? Perhaps because the sky was the one thing the ice and flood could not erase. It was the memory that endured. The constellations we know today, Orion, Taurus, the Pleiades, were already ancient to the builders of the first temples. Myths encoded their motion, gods dying and resurrecting, descending and ascending, disappearing behind the sun like stars behind the horizon. It was as though early humanity, unsure how to trust stability again, projected its longing for permanence onto the stars. But within that reverence for order lies another mystery: the precision of early knowledge. How did Neolithic astronomers know the precession of the equinoxes, a cycle lasting nearly 26,000 years? How did Sumerians measure lunar months with accuracy rivaling modern instruments? Some scholars attribute it to careful observation across generations. Others suspect inheritance, that fragments of older understanding survived the cataclysm, carried as ritual rather than theory. If so, then the first civilizations may have been remembering more than they knew. The myths of a lost golden age, of teachers from the sea, of beings who rebuilt humanity after flood, might not be pure invention. The Sumerian Apkallu, the Egyptian Thoth, the Andean Viracocha, the Polynesian Tangaroa, all arrive from water, bearing knowledge of agriculture, mathematics, writing. All depart when order is restored. Is it coincidence or repetition of a story too old to trace? Modern archaeology, wary of myth, prefers evidence. Yet the earth itself keeps offering riddles that feel like answers in disguise. In the Sinai, copper mines from 10,000 years ago show traces of organized metallurgy before writing. In Peru, monumental architecture at Corral predates the pyramids by centuries, built by people who left no trace of war. Off the coast of Malta, under 20 meters of sea, lie temple-like structures carved from bedrock, their steps worn smooth by hands that never recorded their language. Even genetics hints at forgotten movement. The DNA of early agriculturalists in Europe and the Near East carries markers from regions now submerged beneath the Black Sea. Migration, yes, but also continuity across vanished landscapes. It is as if the flood not only erased, but blended, fusing once separate peoples into new mixtures of memory. And yet, for all their brilliance, these early civilizations shared an obsession with loss. Their monuments were not merely temples, but timekeepers, stone prayers against forgetting. Pyramids, ziggurats, cairns, and circles aligned with solstice and equinox. Architectural promises that even if humanity vanished, the sun would still rise on the same line, at the same moment. The more we dig into ancient soil, the more the narrative of progress feels fragile. Each discovery suggests the presence of a deeper layer, a prior attempt at order that ended in silence. Perhaps civilization itself is recursive, a loop that builds, collapses, rebuilds, each time leaving subtler evidence behind. If so, the Holocene, our age, may be only the latest rehearsal. The myths we call ancient could be memory fragments of civilizations erased by ice, by flood, by fire. We inherit their shadows without knowing their names. In that sense, the rewriting of origins is not deceit, but necessity. Each era must tell itself it is first, or else despair at how little survives. To know that we are merely one version among many might paralyze the imagination. So we forget. Selectively, mercifully. The earth erases with floods and tremors. We erase with stories. But sometimes, through coincidence or resonance, truth slips through the cracks. The alignment of a temple, the echo of a myth, the faint pattern of knowledge repeated across continents. These are the fingerprints of memory trying to return. Perhaps history is not a timeline, but a palimpsest. A manuscript written and erased so many times that only in certain light can the older words still be read. And if that is true, then the question is no longer where civilization began, but how many times. Each age builds its Eden, and each age watches it drown. Yet the impulse to begin again, to rebuild from mud and memory, never dies. That impulse is older than writing, older than the species that carries it. It belongs to the planet itself, dreaming through us, forever rewriting its own origins. Every age believes it stands at the end of history. We measure the past in layers. We name epochs and divide time into boxes. And we comfort ourselves that the line ends here, that the long, trembling story of Earth has at last found its narrator. But the ground beneath us says otherwise. The crust shifts. The magnetic field wanders. The atmosphere hums with the same unstable chemistry that has preceded every prior collapse. The story is not over. It has only paused to take a breath. Look closely, and you can feel it. The faint vibration of recurrence. The same oscillations that sculpted glaciers now shape the weather of our own century. The same gases that warmed the Paleocene sky accumulate again. We stand, unknowingly, at the mirror of deep time, a reflection of the Cenozoic returning to itself. The difference is only scale, the cause no longer volcanic or cosmic, but human. The Earth's lungs still inhale and exhale carbon. Only now we control the rhythm. It is an illusion to think this is new. We are not the first species to alter the planet. Cyanobacteria once filled the air with oxygen and nearly froze the world. Forests once drowned continents in their own decay. Whales, in their age of abundance, fertilized oceans, changing climate more than we imagine. Each form of life remakes the Earth in its own image until the Earth corrects it. That correction is always gentle at first, then absolute. Scientists call our time the Anthropocene, the age of humans. But perhaps it would be more accurate to call it the age of awareness, the moment the planet realized it was being observed by one of its own creations. Through satellites, telescopes, and archives, Earth is finally looking back at itself, recording every tremor, every cloud. We are its memory externalized, the neurons of a planet trying to remember what it once was. Yet awareness does not always bring wisdom. The same curiosity that reads ice cores also burns coal. The same hand that maps ancient stars launches weapons into orbit. Consciousness, it seems, still struggles with responsibility, Somewhere between science and myth, we begin to recognize the repetition. Rising carbon, melting poles, mass extinction, all familiar motifs in the Earth's script. Each Cenozoic warming has ended with adjustment, but never without loss. The difference this time is speed. What once took 1,000 years now unfolds within a human lifetime. We are not watching geology. We are participating in it. If the planet could speak, not through earthquakes or storms, but in a language we could bear, what would it say? Perhaps nothing. The Earth has always spoken through silence, through the rearrangement of what we call permanence. Civilizations mistake quiet for consent. But silence can be a warning, too. The thin line of now, this brief interglacial, this heartbeat between cold breaths, is narrower than we think. The Holocene began just over 11,000 years ago, a blink in planetary time. Its stability is an anomaly. Steady temperatures, predictable rains, mild oceans. Every field, every city, every written word depends on that equilibrium. And equilibrium is never permanent. The data are clear, but the emotion they carry is harder to face. In the same layers of ice that record the Younger Dryas and the Pleistocene's end, future scientists will find ours. A sudden spike of carbon, traces of plastic, isotopes of cesium, soot from uncountable fires. To them, we will look like an event, not a civilization. A horizon layer, a signal of disruption, thin but unmistakable. We call it progress, but perhaps it is the continuation of a pattern older than the species. The tendency of life to push the balance until it breaks. If intelligence is the universe becoming aware of itself, then perhaps extinction is that awareness reaching saturation. The planet remembers what we forget, that all creation begins with erasure. Yet not all erasure is loss. The Cenozoic has taught this again and again. After fire comes forest, after ice comes bloom. Even collapse has a strange fertility. When an ecosystem falls apart, niches open. When a star dies, elements scatter. The universe recycles itself endlessly, indifferent to the scale of its creations. The question is not whether Earth will endure. It will. But whether the consciousness it grew through us will survive its own reflection. In ancient myths, the end of an age is never final. It is a turning of the wheel, a renewal through remembrance. The Hopi speak of worlds destroyed by fire, water, and ice, each reborn through wisdom. Hindu cosmology divides time into yugas, each shorter and darker, cycling toward dissolution before starting anew. Even physics whispers the same refrain. Entropy leads not to oblivion, but to transformation. Perhaps we sense this instinctively in the fascination with apocalypse that fills our art and dreams. We do not fear the end itself. We fear being forgotten by the earth that made us. Yet maybe that is the only kind of immortality we can claim. To become part of the record, like a thin band of ash or a fossilized gesture, preserved in stone. The earth is full of such messages from beings who never knew they were writing. A leaf imprint, a footprint in volcanic dust, a skeleton turned to opal, all saying the same thing. We were here. We touched the light. We became part of the story. And perhaps that is all the planet ever asked of us. Not dominion, not salvation, but witness. To remember. To feel the continuity between what was and what is still becoming. When we look into the night sky, at the constellations our ancestors carved into myth, we are looking not outward, but backward. The light we see left those stars when glaciers still ruled the north. Every photon is a fragment of the past, reaching across space to remind us how brief the present truly is. We live inside that flash, a single shimmer between one epoch and the next. If history has a direction, it is not upward, but inward, into deeper remembrance. The Cenozoic, from its fiery birth after the dinosaurs to this luminous edge of now, has always been a meditation on memory. The planet forgetting and relearning itself, species by species, thought by thought. We are its latest recollection, and possibly its last before silence returns. But silence need not mean absence. It can also mean completion. When the last human voice fades, when language dissolves into mere wind, the earth will continue to turn, carrying in its layers the record of everything ever loved, ever made, ever lost. Maybe that is enough. Maybe the purpose of awareness was never to save the world, but simply to notice it. To look once, fully, before the light changes. And as the line of now stretches thinner, between ice and flame, between memory and forgetting, perhaps that is what we are doing at this very moment. Holding our breath with the planet, listening for the next pulse in its infinite, unfinished dream.